Okay, so tonight we're going to keep going with switches. What we're going to do is add some functionality to switches. We talked about layer 2 switches, and we had the collision domains. And that was the big deal with switches, as they create collision domains. What we want to be able to do is create broadcast domains. And we can do that with a switch with a thing called a VLAN, a virtual local area network. Local area network, generally an IP subnet that is connected together with a router. So virtual local area networks, we create these things on the switch with a simple command VLAN and then whatever the number is, and then you can give it a name. After that, we assign ports to those particular VLANs, and then we're going to get into access ports and trunk ports when we do these things. So the objectives, LAN, there are actually fewer objectives than there were the last time, I think. But LAN switching technology define VLANs, describe how VLANs create logically separate networks, and the need for routing between them. We could actually create isolation of computers by putting them on different subnets on the same network. Then only the ones with the subnet A could talk to subnet B, or subnet A and subnet B could talk to subnet B. But we wouldn't have created broadcast domains because they would all still be in one big broadcast domain. But what we do with VLANs is, using the configuration of the switch, is to break the ports up into broadcast domains, and they don't cross VLAN boundaries. And the IP routing technologies, it says configure and verify, enter VLAN routing, router on the stick. What we're going to do there, they've got figures, but they're basically three ways. We could have the VLANs, and we could plug a Ethernet port or fast Ethernet port into each VLAN, so that the router would have to have the same number of ports as we had VLANs. What a router on the stick does is takes one port, and it actually uses the trunk, and we talked a little bit about trunking the last time. It's got all of the VLANs on it. We create a trunk port on the router. It goes into the router. It then does the routing for the isolation. And they talk about single point of failure. I think that they talk about single point of failure when it's convenient. They talk about a router on the stick being a single point of failure. Oh, we're going to use a layer 3 switch and we're going to route with it, which we can do. Guess what? Still a single point of failure. If we had a router with 8 NICs, it's still a single point of failure. So you're going to have those. When you go into, if you go into the CCNP, the more advanced Cisco stuff, they have redundant protocols, hot standby routing protocols, so that you can have standby routers. If one goes down, it automatically comes up and routes your traffic. It's going to get expensive because you got to buy the bandwidth, you got to buy the ISPs and all that other stuff when we do to it. And then configure SVI. Say again.
When you're not using them, they sit there.
When they're not using them, you sit there. Although some of the protocols will actually parallel them. And then if one goes down, the other one takes the full load, which is a much better deal because you do get to use it, and you don't have to have something that's right. A lot of time it's just there. SVI protocols, we're going to configure virtual interfaces, switch virtual interfaces, which is going to be on a layer 3 switch. New term, what a layer 3 switch is a switch by default, but we can make it route by giving a really complex command, IP routing. Just you have to turn IP routing on a layer 3 switch because by default it's a switch. What you can do then is put the individual ports into a VLAN, and since back to the routing protocols, the router knows about everything that's attached to it. It then knows about all of those networks that are attached to it. So it just routes them all by default. We don't have to worry so much about it. Troubleshoot and resolve VLAN problems. That troubleshooting is a troubleshooting issue. What goes on? One of the things when we get there, in the book he says, all you do is plug the switches in, and since they're desirable, remember we talked about desirable, they form trunks. Well, the packet tracer, and I think they've gone to that as the default, or auto. which means when you plug them in, they're not going to form trunks. So you have to go back and manually, in the lab, you'll have to go back and turn trunking on, which is not that big a deal, and it's good practice to do it. The correct encapsulation is configured. We'll talk about that. There's going to be two types of encapsulation, but only one of them is used anymore. And some of them you have to do. Some of them you have to give the encapsulation command. Some of them only has one encapsulation protocol. So what a VLAN is a logical grouping of network devices. Does that make sense? Does that statement make sense, logic? What is that? What do we mean logical grouping of network devices?
Smart, but they ain't smart.
Let's see if I can make a bad drawing here. How's that? Let's say we have switches here. What logical grouping means is that we're going to group them by subnet. Really, I mean, in plain language, this will be 192.168.1.0 network, and this one might be the 192.168.2.0 network. So each VLAN is a unique broadcast domain. And since these, and we're going to make them a 24-bit mask, 255.255.255.0, then they're each a unique broadcast domain, are they not? Because this one, the broadcast 192.168.1.255, this one 192.168.2.255. But they're not talking to each other. So what we got to do is put a router in here and connect it to each of these switches, and maybe we have a default gateway, and I'm going to say this one, I'm going to do the whole thing, a .1 address for the 1.1, and this one maybe 2.1, so that all of the devices can now connect, because back to the switches know about the networks that are directly connected to it. So it knows how to get this, the router. The router knows how to get from the 192.168.1 to the 192.168.2 and vice versa. So when we connect these things up, unique broadcast domains. What we do when we do a VLAN, let's make our switch longer here. We're going to maybe split it in the middle. And we're going to configure these things. And this half of it is a 192.168.1.1 network, and this one over here is a 2.1 network. And we go in and configure each of the interfaces that we want to be on the 2.1 network, saying, hey, it's on the 2.1 network, and the 1.1 we do the same way. They still cannot talk to each other until we put a router in there. We have created, in effect, two switches on a single switch, virtual switches, virtual local area networks, and they do absolutely divide the broadcast domains. Worried about broadcast. We talked about broadcast. Remember, you get one going, layer 2, it just keeps going. So the router breaks up broadcast domains.
So basically, a switch in its raw form, I guess you want to say, is just a dumb piece of equipment to connect hosts. Yeah. But you saying
we can make it much smarter.
We can make them actually do what a router do as far as designating traffic.
We can break up the traffic. We can't route it.
Oh, okay.
You can designate where it goes.
We can designate. Right. We can isolate them, and we can create the broadcast domains.
Right.
And then we have to put a router in here to connect the broadcast domains. Gotcha. Okay, does that make sense? Yeah. When we do those things. So.
Can we see these notes somewhere? Do you have that right there? Is it somewhere we can see that?
No, you mean my scribble?
No, not the scribble. The thing from Cybex.
Yeah, they're in the resource share PowerPoint. But the PowerPoint, I put the PowerPoints in the resource share.
Okay.
Yeah, and then it basically does go right by the book. So the traffic between the VLANs is restricted, and the devices on the same VLAN can communicate because they're on the same network or subnet or whatever we're going to do. He breaks some stuff up in subnets a little bit later on. Bridges forward unicast and broadcast. Switches, remember a switch is a multi-port bridge. So we on an individual switch, these guys up here are all a broadcast domain, and these guys are all a broadcast domain. When we break our switch up into VLANs on this single switch, we've now created two broadcast domains. And we would have to use a router between them. So what a flat network structure means is they're all a single broadcast domain. It says every broadcast, so it is every broadcast packet is transmitted as seen by every device. And you can get an awful lot of traffic with broadcasts, particularly if we get a storm. Switches, by the way, the dumb device kind of that we connect stuff together, usually have good switches are going to have a configuration that's called storm control that will stop the broadcast storms. So they're a little smarter. And again, if I could only have one device, layer 3 switch, but I think I would pick the switch because it breaks up the broadcast domains, it breaks up the collision domains, a lot of things that slow down traffic, it does. Full duplex, which means if I got 100 meg, we'll get 100 meg in each direction, which effectively gives us a 200 megabit connection with these things. So the benefit of the switch, and this is the same thing that we did last night, or Tuesday night, is we create the MAC address so that when we go from one to the other, shows host A sending a frame with host D as the destination. So host A is going to go to host A, sends it out. It goes out this direction. Doesn't go over here because we're presuming that the MAC table is been populated. So it knows that host D is in this direction. And then when it gets to this switch, it knows where host D is. When it comes in, it doesn't send it to this one, doesn't send it to this switch. So collision domains makes it more efficient. Remember, the first time through before the MAC table's populated, it floods the packets out all the ports because it doesn't know where anything is and waits for the reply. When it comes back into the switch is when it populates the MAC table. One switch, one VLAN. When we talk about these things, and these are what I did with my scribbles a while ago, what we do is take this switch and we're going to divide it in half, let's say. Half the ports are going to be on the sales VLAN, and it might be like VLAN, 5. And this one might be on VLAN 10. You pick the number. You can also pick the name, so you can name these things, and these are named, and then the command that we would type to create would be like VLAN 10, and then the next command would be name admin. So VLAN 10 is now named admin. It just helps kind of keep things sorted out when you start looking at, oh, I got a VLAN 10. Okay, who does that go to? You're going to know, but somebody comes in behind you, they may not know. So all the hosts in a small company are connected to one switch, meaning all the hosts will receive all the frames. Actually, we haven't divided. We'll pretend that we divided it up. Before we divide it up, everything gets all of the broadcasts. So I jump around. I actually took slides from a couple of different presentations. They're all Cybex presentations, actually. I took some stuff from Sage also. So the VLAN Basics and the VLAN security and network management. Security because we have smaller networks. And it also, if we have a hacker gets onto the network, it's not always obvious where everything is. Now they're going to eventually find it. They're going to eventually figure it out. And there's a lot of tools now that will help you find those things, huh?
Unless they're shut out beforehand.
Yeah. But it does increase it in management. If we got a bad nick on, and we'll pretend that we have a VLAN, that these different VLANs in one big switch, okay? And they have some big switches. They have switches that have hundreds of ports on them. So if if you bought one of those things, probably a $50,000 switch. But if you bought one of those things, then you probably want VLANs, because if you had 500 ports, can you imagine what a big broadcast domain that would be? Slow things down. But if we get on these things and we get something with a bad NIC, a dirty NIC, one that just keeps going up and down or generating traffic, we've only affected this network and not all of the others. And all the others are still clean. They don't have that issue. It is a broadcast domain. We probably beat that to death. Divides the network into smaller networks. We beat that one to death. Lower susceptibility to broadcast storms because there are fewer devices on it. Fewer things to generate the broadcast storm. Broadcast storm, I'm just going to go through the points here. VLAN increases the number of broadcast domains. So we go, the number goes up and the size goes down, which is what we want. Smaller broadcast domains. Reduces the size of the broadcast domain. If a storm occurs when there are so many broadcast frames caught in the layer 2 loop that all available bandwidth is consumed, consequently no bandwidth is available. And I told you my story, and yes, you can create those things by looping them back. And this was on a hub, I looped it back, and all you got to get is one broadcast, and it just keeps going around and around and around and around, and it starts milling on itself, one broadcast packet. Because at layer 2, there is no way to stop these things. At layer 3, we're going to have a hop count, which tells us how many routers it can go through before it kills the packet. Layer 3, we can do that, and it makes sense in it, because what creates broadcast domains? That was the router. Routers create broadcast domains. Switches create collision domains. Hubs at layer 1 create one enormous broadcast domain. So they are, and in this world today, you're probably not going to see hubs very much anymore at all. To improve security by isolating users, I've told you the story about the students when they were all on one big subnet. We had the advanced students down here, and we had the basic students down here, and a Windows class, and they would all use the same password, because that's what you do. It's the only way you can really grade stuff. So what these guys would do would be go get on their machines and mess them up. And they didn't really appreciate that a whole lot, as you might imagine. But when we break these broadcast domains up, they can't see them. So they can't find them readily. They have to actually know the IP address in order to get there. Broadcast domain in Windows, you're going to probably see all of the computer names. Now you can turn that off, but by default you're going to see all the computer names if it's one big broadcast network. Huh? We're going to see the broadcast. We're going to see the broadcast names, and then we can ping it, and we can get the IP address, and then we can ARP it, and we can get the MAC address and send traffic there. And that's kind of the process, how these guys got there. So when we broke it up, we caused a lot less frustration with these guys down here that were just starting. And they really didn't miss it. They'd do something stupid like go and try out their command line skills, and they would get into the system, open a command prompt, and change their password or something like that. They couldn't get on their computer or make users for them. Something. I mean, it was nothing really dramatic, but when you're first starting, it really is a pain. Scalability, flexible way to group your users. One of the really cool things that we can do, and we're going to get to more of these terms. I know I'm throwing some things out. We could have, we say this was VLAN 1. We could have users over here on VLAN 1. Different switch. And we create what's called a trunk port, and then we got VLAN 2 over here. VLAN 2 is its own broadcast domain, and we got some VLAN 2 guys over here. These are all in the same broadcast domain, because the trunk port, the thing that connects the switches together, actually has all of the traffic, and we'll look at how it does that in a minute. So it has all of the VLANs. one of the things that they say, an access port, and we talked about access ports the last time a little bit. An access port can only be on one VLAN. Updated to one VLAN and the voice VLAN, because voice over IP can be, you can actually have two as long as one of them is the voice VLAN, as long as it's a telephone on the one. Simplify adding and removing resources, because if we then added another one and we added a user down here on VLAN 1, all we have to do is say that's on VLAN 1. Connect our trunk port, and this guy who's, I don't know, 3 buildings away or 3 floors away or whatever is now on the same network as these folks, because this was VLAN 1 and we put him on VLAN 2. We put him on VLAN 2. VLAN 1's the default. Everything's on it to start with. So we don't really use it. One switch, 2 virtual local area networks, if we beat that to death. Configured one switch, and what he's done is we'll tie these things together in one big box so that they are in fact one switch. But they're on different virtual local area networks, the sales and the admin, with different hosts on it. Access ports. An access port is one that we connect the end devices to. End devices, computers, printers, whatever we're going to send data to and from. An access port belongs and carries traffic on only one VLAN, or 2 if we have a voice. The voice VLAN is the exception here. And then we have trunk access ports, 1 for each VLAN. So each of these machines is going to be on a VLAN. And what he's done here, if you'll notice maybe a little subtly, is the admin is blue and the sales look like they're probably green, maybe dark green. And a lot of times what they'll do, and I'm not quick enough on the color changes on the pins. I'll say maybe I can be with the mouse. We have, first of all, we have the blue ports. These are the dark blue ports. And then over here, the green or the red or the whatever else. I want to use red, so that is something really different. We have the red ports. So the red ports talk to the red ports. The blue ports talk to the blue ports, and the colors represent a VLAN. We also have in here access ports, 1 for each VLAN, and we're going to have a different slide. I'm just going to go ahead and put it on here. We're going to have a trunk port. Well, actually, no. One for each VLAN. What he's done here is we have the red ports here connecting together on the switches, and the blue ports connected. I got ahead of myself. We'll use his color. Try to use his color. Blue here, different color. The blue ports are connected together, but they have to have a connection for each VLAN. For each of these things. So because an access port doesn't look at the source address, the tagged traffic of frame added VLAN information can be correctly forwarded only on trunk ports. So we'll go over here. We have trunk ports. He did away with these colors. I'm gonna have blue ports, and I'm gonna go back to red because it's well, didn't change the color, did it? And the red ports. That's not good because you got a red link there, doesn't it? What the trunk line has is it has the red traffic and it has the blue traffic. So it has the blue traffic. So it has all of these things. What it gets is a tag. So a trunk line is 100 meg, 1000 or gigabit point-to-point link between the switches, between a switch and a router. We're going to look at the switch and the router when we do the router on a switch. Carries the traffic for multiple VLANs. Actually, all of them says 1 to 4094, and we can actually only make up, without doing some other configuration, I think maybe we'll look at in a second, 1024 is around 1,000 VLANs, but that's still a lot of VLANs. I mean, that's a big network if we do these things. So what these things get in the layer 2 is they're going to get a tag put in them. It's going to tell it which VLAN it's on. As it leaves the switch, when it goes that leaves the switch, it's going to be tagged traffic. The tag traffic has a tag in it. When it gets in here, the tag's stripped out, because if you send tagged traffic to a computer, it don't know what to do with it. It's looking for a standard layer 2 packet. We're going to see that here in just a second. So create a trunk, use a crossover, or if it's auto detect, obviously use whatever you want. And I said at each end, yeah, I'm stumbling here on it. At each end of the crossover cable will be connected to a port on either switch. Must not be in access mode. And as far as I can tell, and I couldn't find anything definitively say, oh yeah, they quit using that desirable, because remember, we connected 2 ports together, switch to switch, that were in trunking desirable, they'd automatically create a trunk port. As far as I could tell, and I did several of them on Packet Tracer, they're all now auto, which means that if we configure one end to trunk, the other end will automatically be configured to be a trunk port. But they won't, when you plug them in, automatically be a trunk port. He makes that assumption in the book. So when you're doing the labs and you plug the 2 switches together, they're not going to automatically become a trunk. You're going to have to do that. And if you don't do it, the layer 3 switch won't work, because, or actually probably the router on a stick won't either. You have to specify a trunk port for the ports that are there. And a trunking protocol must be used. There are 2 trunking protocols that you may hear. One of them is called ISL, inter switch link. Which is Cisco proprietary, and it's not used anymore. Spelled Cisco, C-I-S-C-O, Cisco. The other one is 802.1q, which is used in the iOS as .1q. So the way you configure when you type it in, you just type .1q, or actually you can type D and tab and it'll tell you .1q. So ISL 802.1q is the newer. The 802.1q is in fact newer. New switches are automatically configured with it, and the newer switches only have the .1q. ISL, Cisco's, and it says obsolete. Some old switches may have it. You're probably not going to configure it, and hopefully they're not even asking any questions about it anymore. They used to ask one which one has a 48-bit frame header or something like that, and that was ISL. The 802.1q is just going to be a tag that's stuck in the middle of it. These statements are in your book. I just put them in here because there wasn't a switch. Switch port mode access forces the port to be an access port with no VLAN tagging allowed, except for the voice VLAN. So you can have it on voice, and the voice VLANs are generally separate, because you don't want people on the data network to be able to intercept the phone calls. You can intercept them and reconstruct conversations. So they're on a separate VLAN.
They're using clients over there where I'm at.
Yeah.
They come with the LAN to the phone.
Yeah, and then to the computer.
From the phone to the computer.
A phone is actually a 2-port switch inside.
Okay.
So and that's why that works. And it can have 2 VLANs because of that, because it is the phone.
Does the split for you.
The phone does the split for you. The phone,
Because I know even
voice VLAN, and one other VLAN.
if
And
they take that phone and go across the damn room and
Yeah.
plug into another LAN,
And
still
it's
the same number
because it knows the MAC
because it's
address.
programmed in the phone.
Yeah. It knows the MAC address when you plug them in. Yeah, that's the cool thing about those. And it's probably a power over Ethernet because you don't take a power supply with you, right? You just plug it in so the power comes through the switch port, a PoE switch. So switch non-negotiate turns off DTP, and we haven't talked about DTP is a dynamic trunking protocol. That's the one that if you set it up as desirable, that will automatically create a trunk for you. But dynamic desirable is proactive. Negotiation will begin if the other side is set to trunk, desirable, or auto. That's kind of a dangerous configuration if we talk about somebody comes in and just plugs in a device and it's able to automatically negotiate a trunk. Then they can put themselves on whichever VLAN they want because the dynamic trunking protocol will allow that. Dynamic auto allows it to negotiate if the other side is set to trunk or desirable, which is a little bit restrictive. Opinion, if it's not going to be a trunk port, it should be configured to be an access port, but you can always change it later if you need to. Switch port.
Say they leave some of ours just open. I think that program is access because like Central, we had to actually port was locked up, tape done whatever.
Yeah.
I went in, found the configuration, plugged in on a different port.
Yeah.
Everything gone.
Okay, the much promised tag field. What we have here is the layer 2 frame. The data frame layer 2 is framed, so we have the preamble and it does the thing. Start a frame delimiter. The destination MAC address is first so that when it gets into the switch knows where it's going to go as long as the MAC table's up to date. So it doesn't have to read the whole packet. It can read that and send it out the correct port. Makes switching faster because there's an older type of switching. It's called store and forward where it read the whole packet and then sent the information out. So in this one we've got that. We've got all this stuff. We've got the source MAC address, length, type, and then in here tag control information. We're going to insert a tag. 33 bits is a priority. 1 bit is a canonical field identifier, what kind of field it is. And 12 bits for the VLAN ID, whatever that is. 1 to 4096, except you have to have extended VLANs configured to go that high. We're not going to do that in this one. So we get this tag put into the layer 2 frame as it leaves the switch and goes into the trunk port. When it gets to the other end, that tag gets stripped out and then it gets sent to the correct port on the destination switch. The reason that it has to be stripped out is it's going to be sent to an access port. An access port is where the computers and the printers and all the end devices are. They don't know what to do with this. The switch does. So it's really only used to get it across the trunk port, and once it gets to the destination switch to get it onto the correct VLAN. Okay? Magic. No, it's not magic. The switches do all of that for you. You just need to know that it happens. And you have to have, and what trunk ports do, trunk ports carry the traffic from all the VLANs from switch to switch. An access port can only be on one VLAN unless it's a voice. Then it can be on 2. An access port cannot be a trunk. So routing between VLANs, we got to have a router. We got to have a router to do this between the devices before it's able to do that. And each VLAN must have a unique layer 3 address. We've already said that. There's no difference between a virtual local area network and a physical local area network, except that we configure the ports on the switch. Inter VLAN routing, we've got the conventional way, and they've got a picture, I think, in the book in here in just a second, where we would take a router, and if we had 4 VLANs, we'd put 4 NICs in it. A router on a stick, we take a router with a single port and essentially make this a trunk port. And we configure sub-interfaces on the physical interface, virtual interfaces on the physical interface of the router itself. And I've got a demo that I want to do, and you've got an activity to do this too. So this is the conventional method here. When we go down here, we have the blue, the red, and the green VLANs, and we have the blue, the red, and the green VLANs. And these guys are going to be configured as the default gateway. And since the router knows about all the networks that are directly connected to it, we really don't have to do anything except start working with it. It's kind of neat that the only time that you really need to create routes is if you're going off your router. Now, you do that a lot, obviously, but they kind of do their own thing here. Traditional, again, this is a different one, but this one's only got 2 VLANs. And this one's showing the trunk port going between these things, and this is not true. This is a router on a stick. I said traditional. We have a trunk port here that would connect this VLAN and the traffic from these 2 VLANs. Oh, I did that well, huh? So we have trunk port. Trunk port's got all the VLANs on it. And we connect it to the switch and make this a trunk port. And by configuring the router with an encapsulation protocol, 802.1q, it becomes a trunk port. So, router on a stick is what this thing is called, because instead of having a port, a NIC for every VLAN, we only have to have one port, one router port. And this is a better picture of that. We have the blue, the green, and the red and the green, and they all go on a single wire, and it's going to be a trunk port. Trunk port. If I learned how to write with this thing, I'd be dangerous, wouldn't it? A router creates, or we can create logical interfaces. Remember, we used, when you were doing the IP addressing interface, fast Ethernet 0/1, for instance, right? And then you put IP address, whatever, and then the subnet mask. When you want to create a sub interface, it would be interface fast ether 0/1.10 or 1.1 or 1. Whatever. What you would normally use here is whatever the VLAN number is. Just helps keep things straight. So if it were VLAN 200, I would have interface fast Ethernet, and I'm going to say 0/0 because the router you're going to get is, he's got in the configuration, I think 0/1, it's going to be 0/0 because I couldn't find the correct module to put in to make it that. So 0/0.100, and that we would use that for VLAN 100. It just makes it easier to keep track of things when you can make it anything you want it to be. It just makes it easier to keep track of it if you make the interface number the VLAN number. The thing that happens here is we have VLAN 10 and VLAN 20. VLAN 10 and VLAN 20 over here. These are going to be trunk ports because these are switches, and a trunk port here because these are switches. This is a layer 3 switch. A layer 3 switch can route. actually it does switching based on IP address and hardware. Our routers route in software, switches switch in hardware. So what we do is we can actually do it two different ways. We go in here and create virtual local area networks. And then we have our traffic that comes in here for both of them. The two interfaces know about each other, and you use them just like another one interface. We create this thing by typing. Remember, you typed interface VLAN 1, which was already there, and you put an IP address on it, and you did the subnet mask and the no shut command, which, by the way, I think he doesn't have in his configuration statements. The no shut command, you have to use that. So we would just go in and type config T interface VLAN 10, and it would be there, and then we put an IP address, whatever, no shut. And then we can do that for a VLAN 20 or however many of them that you want. So we're kind of creating mystery things here, I guess. But what we're doing is creating virtual interfaces. We did that, or talked about it anyway. Actually, I think you did in the labs when we did OSPF. You did the loopback address. The loopback address became a virtual address. It wasn't real, it wasn't physical. We got virtual addresses and we have physical addresses. These are real to the switch. They're just not real that we can reach out and see how you plug it in there. But they actually are interfaces inside this thing. And this is the creating VLANs. This is kind of what we talked about before. We go in here, config, we're in config T, we're in config mode, obviously. VLAN 2, name sales, VLAN 3, name marketing. I mean, and that's all there is to creating a VLAN. They will then be real on that switch. And if you want to see them, you can in the enable mode with the pound sign, show VLAN. If you want to see which are trunk ports, show interfaces trunk. When we show VLANs, and we'll see that if we do the show VLAN command, trunk ports don't show up here anymore. Only access ports show up in the show VLAN command. If you want to know what the trunk ports are, then you've got to go down and do the show interfaces trunk. It's kind of logical that if it's not an access port, it's a trunk port. So if it doesn't show up here, it's probably going to be a trunk port, although sometimes they get lost with weird things. Let's see. You can tell where I got this one from because of the way they spell placing here, huh? Same thing. Well, no, it's not either. What we're going to do, we created the VLAN up here, the switch port config VLAN 2. They didn't name it. So we go down here, and now we want to put interface fast Ethernet 02 on that VLAN. So we go into interface fast Ethernet 02, switch port mode access. And then switch port access, kind of confusing because we're using a lot of the same words in a different order. First, you have to make the port an access port. Switch port mode access. And in the mode, you can say mode access or mode trunk. And then once you make it an access port, you can add the VLAN to that port. You don't really add the port to the VLAN, you add the VLAN to the port. If you had a 100 port switch, you probably wouldn't want to do this 100 times. So here, instead of typing interface fast Ethernet 0/2, if we were going to do 2 through 8, let's say, we would go in here and type interface range. RA will do it. Or you can type the full word, range fast Ethernet 0/2-8. So that will then do whatever actions you do next, and then we could go in switch port mode access. It would make all of those ports an access port.
Can you do the same for switch port mode access?
We just did that. That's what we do. You have to add the VLAN to the port.
No, you said you had to convert it to
to an access port.
Can you do a range and access port too?
No. What do you mean in access port?
Like, can I make?
That's what we're doing here. What you say, and then the next one would be switch port mode access. Mode access.
You said you had to make it an access port, and then you have to add the VLAN to
Yeah.
it.
Now we just
Can
did
you have
that.
a
We did
range?
okay. Did a range. A range is just like doing a single port. We did that, and then we would say switch port mode access, and that would make 2, 3, 4, 5, 6, 7, and 8 access ports.
Okay.
If we wanted to add them all to VLAN 10, we would say switch port access VLAN 10 or VLAN 2 or whatever VLAN we wanted to add them to, or add to them.
Or you could do the same thing, range, and add that VLAN to all those that you just converted.
Exactly.
Okay.
And here's a interface range. I got ahead of myself. More interface range. The trunk port interface range, and this is, and I think I've got these already done on the switches that I gave to you for the labs. Interface range, fast Ethernet 0 to 15. This is one of those switches that he's got them going like this, so you have 4 ports connected together. So we do an interface range, interface RA or interface range, switch port FA0/15. And then switch port mode trunk. Actually, that's not true. If you do that, it's going to say, you can't do that because you haven't told it what encapsulation to use. Because by default, it is auto, and you can't put, you got to put the encapsulation, and this is the way you do it. Switch port trunk encapsulation.1Q. And again, we're using the same words, trunk here and trunk here, but in different order to do different things. What does it say? On the switch port, for the trunk port, the encapsulation I want to use is .1Q. If the switch supported it, and if you wanted to use it, you could use ISL. You don't want to use ISL.
So the new switches, do you still have to type that in?
Not all of them. Some of them, and the 2960s that you have, some of the labs are 2960s and some are 3560s. The 3560s are layer 3s. The 3560s and layer 3s, you have to give it the encapsulation command. The 2960s you don't, because .1Q is the only encapsulation protocol that's allowed on it. I think probably the reason the layer 3 switches is you can have other encapsulation protocols like PPP at layer 3. I don't know that. That's just kind of a guess on my part. So the allowed VLANs, when you do this, if we wanted to, we can specify which VLANs are allowed on a trunk port. By default, all VLANs are allowed on a trunk port. But if you wanted particular VLANs to not be there, you can give it the VLANs allowed. Switch port, trunk, allowed, clan, VLAN, not clan, VLAN, and then whatever VLAN numbers are allowed. And then you can show the trunk, and it will tell you that. I'm sure that there are instances that you would want that to happen. I think mostly it's there so that they can ask test questions. The native VLAN is something that he talks about. And he's got one of the activities that I didn't do because I've been through this before. I got really messed up on this on a test one time because I was making the change on the wrong switch. The native VLAN is untagged. And it is available if somebody puts a hub on your network, because hubs don't tag frames. So the native VLAN by default is VLAN 1. Everything's VLAN 1 by default. It takes the untagged ports. It will eventually put a tag on them. But it's one that hackers have figured out a way to use the native VLAN and then append a VLAN number. And once the native gets into the switch, the native VLAN tag because it's native is going to have a tag, gets stripped off, and now they're on the VLAN that they want to be. The recommendation is to make a VLAN like 999 or something like that. Make it the native VLAN. The problem that you're going to get into, and then he does a little demo if you want to do it, is you go in and type on one of your switches, you know, what is it? Interface, switch port, trunk, native VLAN 99. Then you start getting error messages. You have a native VLAN mismatch. You've got to go configure it on all the switches. So you can't just do it on one. You have to do it on all of them.
Anything is connected in the VLAN?
Huh?
Anything is connected through there?
Yeah, it is really, and the reason that people put it out on a 99 something that's not used is you're probably not going to use it. Unless you've got hubs, you're probably not going to use it. This is what it would look like with the show VLAN command, which ports are where, and which VLANs are active. Down here, we have VLAN 1 default, and we have 1, 2, 3, 4, 5, everything basically on VLAN 1 because nothing's happened yet. The VLANs that were created, the sales, the marketing, and the accounting are active, but they've not been assigned to any ports yet. So we may have done the switch, created the VLANs. We haven't maybe done a switch port mode access and the switch port access VLAN 3 or VLAN, what are they, 2, 3, or 4 for those ports. The trunk ports, and this is, I think this is a repetition. Interface range FA0, 15 to 18, switch port trunk encapsulation .1Q, switch port mode trunk. Again, you have to do the encapsulation before you make it a trunk port. Viewing the trunk port show interfaces trunk. Showing this the access ports is show VLAN. Show VLAN will show you your VLANs and all your access ports. If they don't show up in the show VLAN, odds are they're going to be a trunk port. But you can show the trunk port that shows their modes, their encapsulation. See, this is an old one. These are actually ISL for the encapsulation. You're probably not going to see that unless you have some really old switches. It won't even be available to you. And then VLANs allowed on the trunk by default 1 to 4094. It's got the output cut. There are some pre-configured VLANs, and I don't remember, we'll look at them. I think they start with 1023. And that's where you bump into it unless you use the extended VLAN. That's where you bump into. You can't make them above that. But still a lot of VLANs. Show interface. Switch port's going to give you, again, a bunch of information. Administrative mode on this one. Interface switch port. Dynamic desirable says it's a trunk port. It's negotiate. It's ISL is the encapsulation. Negotiation is on, and again ISL. This is going to be a really old switch if you have those things. Assigning the ports to the VLAN or assigning the VLAN assigning access ports. Switch port mode access and then switch port access VLAN 3. So first we make it an access port and then we assign the VLAN to the access port. And that's the only. Keep. If you do it in the wrong order, it'll just tell you that you can't do it. That you have to do them. And even if you do it on the test, it'll give you that error message. Just do it the right way. You have the stuff that you have that you're doing in the labs with the error messages. You're getting all that on the CCNA test, the ICND test. You're gonna get the same error message, just unless they've really changed it. And then you can correct the problem as long as you can go in and do these things. So we have multi-layer routing. A multi-layer switch or a layer 3 switch is what we're really talking about here. A layer 3 switch is a switch to start with, but we can make it a router. We can make it route. The first thing we have to do is tell it to route with the IP routing command. You have to do that with routers too, except it's part of the default startup configuration for the iOS. So they automatically get the IP routing command. Layer 3 switches don't. And then we go in here and create interface VLAN 10, the IP address. And then he says in the book, that's it. Well, you got to make these. You still got to have to go in and make these guys trunk ports. Because if they were in fact desirable, by default, they would automatically become trunks. But I said, and it may just be, I don't think it is, I think they've actually changed it. I've looked at the packet tracer stuff and they're auto, and you connect two autos together, they're not going to make a trunk port. So you do these things, and on these, you're going to have to tell it the encapsulation protocol, encapsulation.1q on the 3560, or at least on those packet tracer 3560.
When it comes to trunk, it has to be